怎么都没有人呢？Hello, everyone. Welcome to RIGOL Technology Webinar. Today, I will have you an introduction to how to overcome EMI test challenges. And the subtitles is how to utilize the pre-compliance tool to find the root causes of the problem when you implement the R&D and debugging under the EMI conditions. Okay. So I will introduce myself first. I am Edward Pan from RIGOL Technologies, and I'm in charge of the technical marketing department and doing some technical consultant and support around the worldwide. So today I am glad to have these sessions to introduce these topics, how to overcome the EMI test challenges to all of you. And if you have any technical questions, welcome to raise up your valuable feedbacks in the chat area when I stop the one sessions, and we can check if you have any technical questions. And we will have a proper discussion in further. Okay. Okay. So we going down for the next session. Next slide. So today's agenda, we can separate for 5 parts. The first one, I will introduce the fundamental concept of the EMI, and I will focus on the EMI standard and the test structures to help you to understand how we can implement the EMI verification in advance and how to set up a test environment in further. And I will introduce RIGOL compliance, pre-compliance test solutions in the EMI market in the electronic industry. And the fourth one, I will introduce brief packages of the RIGOL product portfolio and how to implement the EMI test by RIGOL Technologies. And the final one, we will have Q&A sessions and to invite all of you to discuss in further. And of course, I will have a live demonstration of our EMI test solutions after my presentation. Okay. Okay, so let me start for the first sessions. Okay, so we can see the topics. What is the EMI in our daily life? So it is very attractive and simple questions around our life, because the EMI surrounding us everywhere, yeah, included the like the thunderbolt discharge, yeah, from the raining weather, and it is the huge impact of life of the EMI, electromagnetic interference. So it is very important when the thunderbolt impact our electronic product, it can be destructive our product or interrupt our functionalities of any electronic equipment. Okay, so you can see the right hand side of the display. We can separate the EMI for two parts. The first one is the radiation parts. So the radiation electromagnetic field is transmitted around the air, and the interference without any cable or media. Yeah. So it means it is the EMI from the radiation part. Yeah. And the other one is the conduction part. That means the EMI interference coming from the media and the conductors. Yeah. So you can see one part of the EMI coming from the wire line, such as the power core or from the city power. And the other one is the radiation part from the electronic equipment itself. Yeah, so it is simple to let you know the two parts of the EMI generation root causes. Okay. So for the next slide, we can know how EMI impact our life. Okay. So as you know, the first one we have introduced, that is a thunderbolt. It is a very general electromagnetic interference around our world, around our environment in our life. And the second one is the radio emission. As you know, each kind of electronic product, if we generate the current from the amperes law, yeah, the current will generate the magnetic field surrounding the current. Yeah, so it means it will have the radio emission, yeah, around our environment. Yeah, and the third one is the digital circuit. That means we have many kind of digital circuit inside our equipment. Yeah, because it excluded the analog part, like the 1010. Yeah, because currently our market trend will implement some kind of a high-speed digital transmission. Yeah, included the transmission line. That means we will generate the EMI interference and interference each others together. Yeah, so it is a very simple one to understand how digital circuit can impact our electronic equipment in advance. And the fourth one is the pulse circuit. The pulse circuit, it means we have the switching power supply. Yeah, because we have analog switch, high-speed switch, analog type the switch. So we will generate the EMI radiation from the source. Yeah. So you can see the diagram as the bottom side of the display. So you can see the EMI source and the EMI receptors. We can separate for two parts. And we have the coupling paths, including the air or the media. If we transmitted the EMI from the air, it means has the radiation emission. If we coupling paths included the conductor paths, that means we have the conduction emission. So the EMI will degrade our electronic product performance, and it will cause the functionality failure, and even it may cause the equipment damages in further. Okay. Yeah. Okay. So let me see some kind of introduction to the categories of the EMC. Yeah. Before we discuss of the electromagnetic interference, that is called the EMI, we will back to the basic concept. That is the EMC. What is the EMC? EMC is the electromagnetic compatibility test. So it can separate for two parts. The first one is the EMI, which is the major topic we discussed today. But the other one is the EMS, that is the electromagnetic susceptibility testing. Yeah, it is different things because EMI, it means our electronic product under a EMI environment. That is the how to interfere with other equipment. So we will to validate the EMI qualities and the procedures in advance. But the EMS means how we can accept and accept the EMI interference from the other equipment. So it is the total different things we discussed. But today we will focus on the EMI, the interference part. And the EMI we can separate for the other two parts, that is the conduction part and the radiation testing parts, which I mentioned for the previous two slides. Okay, so it is quite simple. I think all you guys can understand it well. Okay, so for the second sessions, we will going for the EMI standard and the test structures. So it is quite important that before we well known about the electromagnetic interference, we need to well known about the EMI standards. If electronic product we want to ship out to abroad and to sell the product to the other countries, different countries have each kind of the EMI validation categories by each country. So it has different kind of the standards around the worldwide. Okay, and we will set up a test structures to introduce you how we can implement the EMI test in advance. Okay, so the first one we can see each kind of the validation standards categories we can separate for, like the left one, it is the CISPR standards. So the CISPR standard means this is a committee, international special radiation committees. It will be public standard around the worldwide. So the CISPR is a general standards of the EMI. The second part, you can see this one, FCC is a Federal Communication Commission. It is generated from the North America. Yeah, it means if you want to ship out your product to the US or Canada, it will be passed or validated by the FCC standard. Yeah, so we can see that EMCC, like the part 18, 15, it will be included some kind of standards to specify the EMI standards in advance. And the third one is the EN standards. EN standards is coming from the Europeans, the territory. Yeah, so if you want to validate it by the European territory, you need to pass the EN standard. For example, if you want to pass like the laptop or PC product, you will pass the EN 55022. It belongs to the information technology equipment. If you want to ship the automobile electronic product to European, you need to pass the EN 55025. It belongs to the automotive product standards. So it is quite simple to let you know this kind of the standards which you want to ship out the electronic product broadly. Okay. Okay. So for the next slide, we can see if we want to pass the standards, you can see the left-hand side of the screen. Like this one, we have limit line on the test environment. So it has many kind of the EMI peak on the display. Yeah. If the peak is surpassed the limit line, it means it will be failed of the EMI standards. So it will appear the red mark specification parameters on the display. It means you have some tolerance to pass for the standards. Okay. So it means the failed result. So if we encounter the failed result, we will go for the debugging. So each kind of the R&D engineer want to do the circuit debugging to find out the root causes of the problem inside the electronic circuitry. Okay. After you find out the root causes of the EMI root causes, we can take some actions to resolve these issues. For example, such as the first one, we can add some kind of common choke solutions to reject the EMI radiation inside the circuitry. For example, such as the second one is a metal shielding strategies. It is a passive actions because if we confirmed about the circuitry design infrastructure, that means we cannot guarantee and negotiate with the infrastructure again. So we need to use the metal shielding strategies to avoid the EMI interference between the other environment and between the environment and the electronic product. And the third one is the grounding issue resolving. If we have a better grounding infrastructure, that means we can have a better EMI rejection actions. Yeah. And the fourth one, that means if we cannot reject serious the EMI phenomena, it means your circuitry need to be re-layout in advance. It is unlucky things if you encounter this kind of phenomenon. Yeah. Okay. So after we do some actions to solve the EMI issues, we will see this phenomenon can be passed. That means all the EMI paths will be below the limit line and to do the pass result. So it means we can find out the root causes of the problem and pass the result. Okay. So this is a necessity of the pre-compliance test tools. Yeah. The major one, we need a spectral analyzer to do the EMI test included of the software environment. And the other one, we will need to set up a near field probe to check about the EMI source surrounding the circuitry. Of course, if you want to implement the formal EMI validation in the chamber, you need the big size, the antenna structures surrounding the chambers. Yeah. Of course, the linear impedance stabilization network, it is equipment which will be offer a good impedance matching and to reject any kind of the other unnecessary EMI noise source from even from the source, the CD source or the other equipment. Okay. Yeah. So it is a brief infrastructure and the necessity of the pre-compliance tool. Yeah, from this presentation slide. Okay. So we will introduce you about the test categories of the EMI. Of course, as we mentioned for the previous slides, the EMI test separate for two parts. The first one is a conducted emission test, and the other one is a radiated emission test. Okay. So it is very simple to let you know. You can refer to this kind of figure on the display. Okay. So let me see how we can do the EMI test by the conduction test. Yeah. So what is the definition of conduction test or radiation test? I will have you a simple judgment. The judgment conditions. That is, you can remember one parameters. That is 13 megahertz. Yeah. If we want to test the frequency, EMI frequency above the 30 megahertz, it belongs to the radiation test part. If we want to implement the EMI test below 30 megahertz, it means we will belong to the conduction part. Okay, so for the conduction part, the frequency generally will be have from the 150 kHz to 30 megahertz. Okay, but for the FCC standards, it may start it from the 450 kHz. Okay, so it depends on different kind of the standards as you want to following the standards as you like. Okay, so the required test rule, of course, we need the EMI receiver. What is the EMI receiver? For example, for the RIGOL's part, we will offer you a very unrivaled weapons that we call the spectrum analyzer, yeah, or the EMI receiver. Okay, the other one is a listen, that is a line impedance stabilization network. I will introduce you the principle of the listen for the latter with the next presentation slide. Okay, so of course we need the shielded enclosure of necessary test requirements, etc. For the EMI radiation test, of course, it is belongs to the above the 30 megahertz to 1 gigahertz. Yeah. So it is very simple, the same as the previous slide. We also need the spectrum analyzer to retrieve the signal which you want to test. Of course, you need the antenna to do the radiation test, such as the near field probe or the standalone antenna. Yeah. Okay. So it is the radiation test categories. Yeah. For the conduction emitting test structures, the major one part is a listen. So I will introduce you how the listen work in this infrastructure. Yeah. So you can see the listen will connect to the city power and to connect to the equipment on the test here. And before you send the signal to the spectrum analyzer, the middle will connect a transient limiter. Yeah, because we need to reject any kind of the unwanted transient generated by the EUT or listen. Yeah, like the thunderbolt or the other kind of the switch noise from the other equipment. So we need to add some kind of the transient limiter to reject this kind of the noise from other equipment or other environment. Okay, so you can see the left-hand side of the circuitry. It is a very simple RLC circuitry. Yeah, it is quite simple. As you can see from the left-hand side, from the power source, it will directly connect to a inductance. As we can know, the circuitry courses when we enter the university, as you know, the impedance of an inductance that will equals the J omega L. When the frequency increase, that means the impedance will increase as the frequency increasing simultaneously. So the city source, yeah, will be the city source can smoothly passing this inductance to the equipment on the test. But the other kind of high frequency noise source will be rejected by the inductance and going through the capacitors to the ground. That means the grounding, as we know, the impedance of the ground is the 1 over J omega C. That means the high frequency we're going through the lower impedance of the which were generated by the capacitors to the ground. So it is a very simple RLC principles. So from the right-hand side, that means the noise source which we want to test by the EMI. So if we want to avoid the test signal back to the power source, So we need to use inductance to reject the high frequency noise. And the high frequency noise will leading to the capacitors to the receiver side, going to the spectral analyzer. So it is very simple one to let you know the scenario of how the listen work. Okay. By the other side, the listen will provide a very stable impedance matching when you connect it to some kind of such as the 50 ohms infrastructure or the other kind of the impedance structure. Okay. So this is a very detailed layout infrastructure for conducted emission test. So including the table or the distance between the wall and table, it has a standard document to define the distance and the table's height, even the table's width or the table's length. So it is very serious definition for the conduction emitted test. Okay. So for the radiation test, the general one for the formal radiation conduction test is like this one, is the far field measurement. If you want to send out for the validation of your product, you will send your product for validation in the EMI chamber for the formal verification center. Before you send to the verification center, even you want to find the root causes of the EMI source, we can buy some kind of spectral analyzer in your R&D environment, and you by using the near field probe to find the root causes of the EMI surrounding your circuitry. So it is a very simple one and cost-effective tools to help you to implement. So we call it as the pre-compliance test tool. Okay, so it is a simple principle to separate to define the far field measurement and near field measurement. Okay, so let us going to the next slide. Oh, that is the formal antenna, like this one, biconical antenna or the broadband Yagel antenna or the periodic log antenna. Yeah. So these antenna are usually used in the formal verification center. Yeah. Yeah. If you want to do the pre-compliance test tool, it is unnecessary. Yeah. So it depends on what you want to do. Yeah. For the EMI test. Okay. Okay. This is the first two sessions which I introduced you for the previous slide. So we can hold on here and to have some discussion. If you have any questions, welcome to raise up your questions in the chat area. I can help you to digest for the previous slides. Yeah. Okay. So any of the questions for the previous two sessions, which I introduced to you already? Yeah. Okay. Any questions? You can key in your characters and questions in the chat area. Okay. Okay. What is the AC and DC lesson? Oh, AC and DC lesson. That means different type. That means we have the DC source, and the DC source directed from the DC supply. That means you can connect it to the DC power supply, like a switching power supply. For the AC lessons, that means we can directly connect it to the city source. So the lesson have different kind of categories. So it will separate for even 8 to 10 categories of the lesson. Yeah. So I will not introduce more about the detailed lesson categories for these sessions. Okay, so I can just roughly tell you about the AC and DC lessons when you implement the conduction test. Okay, any questions? Okay, if you don't have any questions, I will go for the other sessions. Okay, so I will introduce the RIGOL pre-compliance test solutions. Yeah, okay. Okay, so what is the pre-compliance test solutions? We can see these figures. Okay, the standards, the verification of the EMC is a far-field test. When you send out your product broadly, yeah, you need to pass the standards of the validation. So the field test can deliver the frequency message, but cannot express the EMI location. Yeah. So if you have a failure result in the formal validation centers, but if you want to do some debugging actions in the validation centers, the validation center will charge you a very expensive fee to stay in their the validation center. So it is very expensive, it's not cost effective. So if you want to realize the debugging of your circuitry, we can use a near field testing. Yeah, that means we can do some kind of a near field testing around your circuitry to find out the root causes. Yeah, before you sending your product to do the validation in the formal validation center. So it will save your debugging expense in the validation center. Yeah. So how we can implement this kind of pre-compliance test tool? Yeah. That means we need to use very cost-effective tools. That means test and measurement equipment. So that is the spectrum analyzer. Yeah. So for the RIGOL's spectrum analyzer, we have a very cost-effective performance to all of your customers around the worldwide. So we will have some performance like a sensitivity, resolution, frequency response, and a better environment of the measurement and analysis. Yeah. Okay. So it is depends on how what kind of the model number you want to choose for the EMI test. Okay. So the other one is the near field probes. So the near field probes, it means we will have a kind of a near field probe to help you to find the root causes from the larger size to the small size. So the larger size, we can from the 10 centimeters. So it can scan surrounding the circuitry to find a rough position of the root causes. And then we can switch to the smaller one to have a more accurate positioning. Yeah, root causes position. So totally we can down to the 2 millimeters. That means we can contact the root causes of the pin number of the integrated circuitry inside the packaging circuitry. Yeah. So it is very useful tool to help you to have root causes positioning and root causes finding. Yeah, when you doing the R&D debugging. Yeah, so it is a very good tools to help you to solve the problem in advance. Okay. So the other one is the test tools. So the test tool is a kind of software environment which built in inside the spectral analyzer. Yeah, so like this one environment. So don't worry about that. After the presentation, I will have a brief demonstration to help you to understand how we can implement the EMI test under this test solution, test software. Okay. So this is some many kind of versatile functionalities inside the software and assist you to do the circuitry debugging and find the root causes. Okay. Okay, so we will go for the fourth part, that is the RIGOL product portfolio. Yeah. So how we can, the RIGOL's product portfolio, like this one. This is the RSA 3000E series real-time spectral analyzer. Yeah. So the first one, I need to introduce you. The bandwidth is just 1.5 gigahertz bandwidth. Yeah. So because the standards of the EMI standard of the radiation part, the upper limit specification is under 1 gigahertz. It means 1.5 gigahertz, the spectral analyzer is just enough. Yeah. So the 1.5 gigahertz, the spectral analyzer is just made to help you to implement the EMI test under the specifications and the standards. Yeah. And we have the 10 megahertz real-time bandwidth and have versatile options like the EMI application and the ASK, FSK demodulation functionalities. Yeah. And we have the touch screen functionalities and the gesture phenomena. Yeah. After the presentation, I will have a live demonstration to introduce all of you to see the real demonstration. Okay. So we also have the 10.1 inch capacitive multi-touch screen. So you can use one finger to select any kind of the measurement parameters on the display directly. Yeah. Okay, this is a brief specifications of our products. So this is a products family portfolio to let you know we can have the higher end spectral analyzer up to 6.5 gigahertz and have the lowest frequency we can up to the 5 megahertz. So if you want to implement different kind of test requirements, so you can directly contact your local distributors to have the quotation of the spectral analyzer, each kind of spectral analyzer. Yeah, so we will immediately offer you the price and quotations in advance. Okay. Yeah. So the final one, before the Q&A sessions, we will do the live demonstration to all of you. Okay. So let me switch the screenshot to the other display. Okay. So this is a screenshot of our spectral analyzer. I'm sorry, the camera is a little bit not enough resolution, and we have an environment-like reflections on the display. So maybe you cannot see very clearly on the display, but I will try my best to optimize the demonstration when I'm doing the demonstration. Okay. Oh, okay. So I will introduce this one. This is the RSA 5000 series N net spectral analyzer. So today I will introducing the EMI test functionalities to all of you. Actually, this one is a 5-in-1 test equipment, included the general spectral analyzer and the real-time spectral analyzer, vector signal analysis functionalities, and EMI test tools. Even we can implement the network analysis like the S11, S21 to test the component, and even such as the antenna or the cable. Okay. Of course, the other four is not the topics we discussed today. So I will focus on the EMI test. Okay. So before we want to do the EMI test, I will use like this one, like a signal generator, the DSG 800 series signal generator to simulate the EMI source. Okay. So before we doing a test, the first one, we need to recall the limit line first. Okay. So for example, yeah, we can recall the limit line here. Yeah, press this one. Okay, so this is a limit line standards here. So we can press this one. Sorry, limit line Explorer, File Explorer. So we can change of the file format to the .lim format here. Okay, and we can double click and double click. You can see I use the one finger to use the gesture functionalities to select the menu inside of the display. It is a very inconvenient functionalities of the RSA 5000. Okay, So for example, I will hook up the 55012 standards here. You can press this one. For example, I want to use the 55012 here. Yeah, I will hook up the display here. Okay. Oh, sorry. Exist. Exit. Okay. I will redo this one. Okay. Limit 1, recode the limit explore like this one. Okay, limit en standards here 55012, this one, and press the recall. Okay, so you can see the limit line here, right? Yeah, it is a light yellow limit line. I think you can see clearly on the display now. Okay, so we can do the sweep now. Okay, before we do the sweep the functionalities, we need to set up the scanning table first. Yeah, let me press the measure setup here, and you can see this is the scan table here. First, we can press the scan table. Okay, you can see here it is the frequency setup environment here. So we can separate for this one. We can start it for 30 megahertz. Yeah, and the end of the 1 gigahertz. That means now we do the radiation test range here, and we can set up the points, sweep the point here, and we can set up the scan time, and also set up the RBW. That means the resolution bandwidth here. For the radiation part, the correspondent RBW is the 120 hertz here. So now we have already set up here, settled down here. Yeah. And of course, this is the PA. That means we have the preamplify. So we can turn on the preamplify first. Let we preamplify on. As you know, if we equip with the power preamplifier, we can enlarge the signal to noise ratio. It is the relative we can set, and we can pull down the noise level on the display, right? Yeah, so it is a basic concept of RF microwave knowledge, okay? So after we set up the scan table, we can log out and measure setup here. We can begin the sweep. Okay, then we press the sweep and start the sweep. Okay, you can see this is a EMI spike here and the other one. So we have a 2 spike. The spike is surpassed the limit line. Yeah, so that means we will have a failure result under this condition, right? So I will have a large EMI test solutions here. Okay, yeah. So this is the continuous swept type. Of course, we can do a single swept type here, right? Okay, yeah, it is very simple. So now we can do the second demonstration and press the measure setup here, and we can do the scan and search only. Okay, the search only, that means we can sweep again, start. Okay, you can see we can have the different we find out the 3 different kind of the EMI spike on the signal table here. The red one means it has surpassed the limit line and have a failure result. If we have a pass result, it will appear a white one, not a red one. Okay, yeah. So we have a major advantage to implement the EMI test because we can implement the peak, quasi-peak, and average test simultaneously. How we can set this? For example, this one is a peak. The other one is a quasi-peak. And the third one is the average standards. How we can implement the 3 test modes simultaneously? It is quite very interested topics. So we can select a measure setup here and doing the scan to the measure here. Okay, now we do the swept again. Press the start. Okay, you can see, yeah, the parameters for the peak result, quasi-peak result, and the average result can be shown on the display simultaneously now. Yeah, so it is the simple demonstration of the EMI test. So it is a very good tool and very convenient to help you to find the root causes of the problem. Now, I will introduce you a very strong advantage phenomena by RIGOL Technologies, that is the power meter mode of the EMI spike. How we can implement this power meter mode? We can press the mode setup here. Yeah, and now, sorry, we need to find out the peak now. And doing the peak, okay. Measure here, pick here, okay. Meter mode here, meter control, and we will now couple to the marker here. Press this one. Okay, you can see the purple one will align to the largest spike on the display now. So we can see the power meters will be enhanced to this top of the criteria now. Okay. So this is meter mode can pull out the spike to definitely to monitor the peak power on the spike here. So we can also separate different kind of meters, like the for example, the detector 1, we use the positive peak detectors. Yeah. And we can set up the limit criteria, such as if we want to use the site criteria is a 60 dB microvolt. Okay, so we can turn on. Okay, so the red part, that means we have surpassed the limit line for the red part. That means how we can adjust by tuning your circuitry parameters when you're debugging. You can monitor the spike peak here. Yeah, so it is very convenient tool to help you to do some adjustment by the peak meter mode. Of course, we can select the meter 2 and we can set up the criteria to 50 dB microvolt and turn on the state. Okay. Okay, you can see the blue one. That is the quasi-peak criteria. Of course, we can set up the meter 3. Yeah. And turn on the meter 3, set up the limitation to 30. Okay, turn on the state. Okay, yeah, it is a quite good result on the display, and we can back to the meter mode to sweep type, and we can do a continuous meter monitoring. Yeah, here, press this one. So you can see this is keep updating anytime here. Yeah, it has a circular loop here, yeah, marker here. So, okay, it is a little bit unclear to show the color. So now it is more clear now, okay. Okay, you can see this is a red one. It's a yellow, blue, green, yeah. Okay. Can you see that? Yeah. It is a meter mode. Okay. So this is the meter mode demonstration. Of course, we can also do the multi-trace application. This is a multi-trace. For this one, continuous trace. Okay. That brings us back to the trace mode. We can have the multi-trace here. For example, I will set up the preset, okay? So we can continue swept here. Okay, and the trace 1, we have the 3 different kind of the trace to that you to compare different kind of the device on the test. For example, for the trace 2, yeah, you can do the trace update and the trace spray and the swept again. Start. Yeah, this is a blue one. Okay, and we can do the trace free. Okay, and we can also trace update here for the green one. Swept. Start. This is green line. So we can sweep the trace for 3 trace, different kind of the trace simultaneous to compare the 3 different kind of the device under test by this kind of functionalities. Okay, this is the whole demonstration I introduced you today. So any questions? Now I will back to the chat area to see what kind of the problem you raise up. Okay, okay. What is the type of power meter diode or thermal diode? Okay, I think it is a diode mode, not thermal diode. It is a general diode to has a simple detecting diode to catch up the signals by the circuitry inside. Yeah. So the second questions I see. Okay, what are the advantages of RSA in the EMI testing, or is it also just the scan mode? Okay, now RSA, the real-time the spectrum mode cannot implement it into the EMI test. Yeah, because we need to use the traditional swept type spectrum analyzer to implement the EMI test, because we need to use a scanning mechanism to implement the EMI test. Yeah. So we don't design the EMI test capabilities under RSA mode. Yeah. Okay. So for the third questions, how to get 3 traces correspond to peak, quasi peak, or average? Okay, like this one. Yeah. Trace. Okay, you need to set up the measurement table measurement here. Yeah. Here, this is okay. I will stop the here single. Okay, single here. So we can back to the setup here, and we can set up the. This is the scan only here, and under the scan only here. This is a detector mode. Yeah, we can press this one. Detector mode, the first one, we can set up the positive peak here, or we can set up the detector 2, we can set up for the quasi peak mode, and we can do the detector 3 here, that is average mode. So you can see the different kind of the swept mode by different kind of the trace. So we can compare to the other kind of the versatile comparison, but usually we need to comparable traces under the same condition. So we usually don't use the 3 different kind of detectors to compare each other. It is no meaning. Yeah, can you understand? Yes, right. Okay, so for the 4th questions, in your demo, you have selected positive peak for all traces. Yes, I use the positive peaks for all traces. Yeah. And the customer want to see traces all the detector instead of direct measurement. Okay, it is quite simple, but of course, yeah. Okay, if we want to select the table to detector 1 to set up to the average. Okay, I set up to the average. So swept again, continue. Yeah, this is the average mode. So you can monitor the average here. Yeah, this is the 12 dB. Yeah, here under here. So this is average test. Okay, yeah. Okay, let me see the other one. No. Okay, don't have any questions. So don't hesitate to raise up the questions in the chat area. it is very glad to have this demonstration to all of you to introduce the EMI test solutions by RIGOL Technologies. Yeah. Okay. So any of the questions? Okay. Okay. What is the importance of the meter? Well, it shows the percentage of the peak available in measurement. Okay, so we can use the meter mode here. Okay, stop here. Single. Okay, meter mode, meter control. So you can see meter modes here. We have the limit. We can have the limit here, and I show you for the previous demonstration. Yeah. Okay, that this one I will have the peak. Okay, so meter mode, meter control coupled to the line here, and this one, so I can set up the meters criteria to 60 dB microvolt. Turn on the state, so you can see this is a deviation from the limit line. Yeah, this is the limit line. And the red one is the surpass part here. So it means we can, if you want to know about the percentage, you need to calculate by the manually. Yeah. So as I see here, yeah, it is just a surpass one. So you can set up here. Okay. Yes, just see this part. So you can calculate by yourself manually to calculate the percentage. Yeah, the red one divided by the total yellow one. That means you can get the percentage of what kind of the passes to the surpass the limit line. Okay. Good. Good questions. All you raised up. So any questions after the presentation and live demonstration? Okay, if all you guys don't have any questions, okay, let me see. Okay, no questions. Good. If you don't have any questions, okay. Oh, one more questions. Okay, why are we using all the magnetic field probes? Okay, the magnetic fields usually doing the EMI test because the current always going through the circuitry first. Yeah, so the electric field is not the major one compared to the magnetic field because the current going through the circuitry by the Ampere's law. Yeah, as you know, we can have the magnetic field surrounding by the current flowing to the circuitry. Yeah, so the H field is a major part of the EMI. So for the EMI status, we usually, the first topic we need to discuss with the magnetic field first. If you want to discuss about the electric field, of course, it is no problem. You can use the formula. Yeah, what is the formula? That is the eta equals the electric field over the magnetic field. So you can get the electric field. That means you can use the characteristic impedance multiply the magnetic field, you can get the electric field. Yeah, this is the major part, the principle. Yeah. Okay, the other questions, how do we know what is the sweep frequency? Sweep the frequency. We don't care about the sweep frequency. We just need to care about the sweep time, not the sweep frequency. Okay. Do you have an amplifier also connect to the spectrum analyzer? No. I just use the internal preamplifier to enlarge the signal to noise ratio and slow down the noise level. Yeah. Okay. So let me swap them again. You can see this one. Yeah. Yeah. We back to the scanning table. Yeah. Scan table. Yeah. Okay. We stopped here. Okay. Okay. Stop here. And we turn off the preamplifier. Okay. Scanning table here. We turn off the, okay, not turn on. We turn on the preamplifier here. Okay, turn on the preamplifier. Now, okay, you can see okay, you can see the noise level will slow and will lower down. Yeah, around 10 dB. Yeah, it is quite simple. Yeah. Okay, how do we know what is okay? Do you have any reply? Okay. Okay. I have answered all the questions. Okay. Any other questions? It's a very good questions all you guys raise up today. And we are glad to discuss with you about any kind of technical issues when you encountered during R&D procedures during your daily life. Okay. Any other questions? Okay. You are welcome. Thank you very much for all of you guys to join today's webinar. And for the next month, we will have more attractive webinar to introduce all of you about the other attractive topics. Thank you very much. Wish you have a good day and a nice weekend. Thank you. Bye. Thank you.